The equation for green hydrogen seems simple. Take water, add renewable electricity, and you get the fuel of the future. But when it comes to producing megatons of hydrogen, we're talking about millions of cubic meters of water. Water that often isn't available where it's required most. And it can't just be any water. Now, I'm an optimist, but if we get the aspect wrong, don't we risk the sustainability and robustness of the entire hydrogen value chain? Hello and welcome to our new episode of Minus 253 degrees Celsius. It's our monthly expert talk that gets to the point, and in fact to the boiling point of hydrogen. And today, actually, we're not just going to talk about the final product, hydrogen for a change, but its most fundamental, perhaps its most crucial ingredient, of course, water. Without huge amounts of water, and not just any kind of water, highly purified water, there will be no green hydrogen economy. Now, to discuss this challenge, I'm delighted to have with me Wolfgang Schleifenbaum. He's the head of product area hydrogen at Bosch Manufacturing Solutions. Welcome, Wolfgang. It's good to have you here.
Hi, Keith. Thanks for having me.
It's a provocative question, but it's the question on everyone's lips. When I turn on my tap at home, out comes water. It's pure enough for me to drink. Why can't we just use that? Isn't water surely just water?
Yes, but please don't use tap water. Running an electrolysis stack on just tap water will degrade it in shortest amount of time, and it will start producing less and less hydrogen. The trouble with tap water is that it has inside the H2O molecules that are needed to feed the electrolyzer stack and produce from it H2, so hydrogen. It also contains contaminants like salts, minerals, metal ions, and those will deteriorate the function of the electrolyzer stack. So tap water is not suitable.
So you're saying we need a very special kind of water. But what kind of water are we really talking about? Is it something I can go to the DIY market and find, like this distilled water?
Only ultra-pure water will make the electrolyzer stack really happy, lasting for many, many years, producing the hydrogen. We measure the quality of the water in terms of electrical conductivity. Measured in units of microsiemens per centimeter, it needs 0.1 microsiemens per centimeter. That's a very low value. The tap water you mentioned, it's 1,000 times higher in that value. And if you consider saline water sources, the ocean, for instance, that value is 500,000 times higher than the 0.1 microsiemens per centimeter needed from the electrolyzer stack. There's a lot to do prior to electrolysis, and that job needs to be done by a water purification unit that's always coupled to an electrolyzer.
I'm an optimist, but I'm thinking, using renewable energy, the first thing you think of is, I can get that from the sun. The sun is mainly there in arid regions, dry regions where, contradictory, there may not be enough water in the first place. How do you deal with this conflict? Where is all this water supposed to actually come from? Are we talking about using seawater? You mentioned it. How are you going to actually do it?
You're right that it is a challenge, and I must also say there's a solution. So we can handle it. So the challenge is water management for us as humanity in the future. And there's a global view on it and a local view. And the global view is that when you look at the consumption of water for the green hydrogen production, even if we go towards net zero, it's vast, but it's not really that much compared to what humanity consumes. And this is globally true. So summing up all the needs for water. But if you look at the exact location where you have a green hydrogen production, then the situation might be absolutely different. There might be no water available whatsoever, or it's a saline water source. You mentioned it, seawater, for instance. So there's a lot to do in order to manage that type of water. Offshore and desert areas are, for a reason, important. There, the renewable energies are really abundant. We know that many hydrogen production projects will end up in such remote locations. And there we have special challenges for water purification. One of them is intermittency. So start-stop behavior of solar or wind energy input will face a challenge to state-of-the-art water purification technologies. We have to keep the maintenance level very low. And sustainability in the sense of water scarcity and chemical emissions is another challenge for state-of-the-art technologies.
Bosch is developing your own water treatment systems.
Yes, you're right. We are introducing into the market containerized systems for water purification, and they are tailored for green hydrogen projects. And they are not Me Too technologies like what is already on the market, but we have really chosen the technology such that it fits the green hydrogen production. I have brought along a toy model. In reality, of course, it's a bit bigger. And we have sized the capacity such that it can provide the process water for up to 15 megawatts of electrolysis. When you look in the inside of this container, you will see what kind of technology we have there. And you see here on this side, a mechanical vapor compression distillation. This is a distillation with a clever recuperation of latent heat. So it's energy efficient distillation. It's coupled to an electrodeionization unit that polishes the distillate water in order to achieve these 0.1 microsiemens that I talked about earlier. Completed is this system by an anti-scaling unit, and that makes sure that without adding chemicals, we can avoid purification during the purification process scaling. This whole system we are introducing into the market, and it's in particular robust, and it's particular sustainable because it can save lots of water. Now we have successfully tested the solution at the Fraunhofer Bremerhaven Hydrogen Lab at the German North Sea coast using seawater in order to simulate the real offshore conditions. Because of the feature that we do not add any chemicals to the process, we were awarded by the Deutsche Messe AG and the Deutsche Wasserstoffverband with the H2 Eco Award. And by the time you see this video, we expect this device to be up and running at our first customer projects in Bangalore, India.
It does seem rather complex, though. You seem to be increasing possibly the complication and the risk of failure and perhaps even the initial investment, the costs. How do you respond to that?
I would say actually on the contrary, we are lowering the complexity. We must realize that water purification is indispensable. We absolutely need it. And what we have to make sure in the entire system consisting of water purification, electrolyzer, transport, and then the usage of hydrogen, we have to make sure that the water purification runs very robustly. And for that reason, we have made it a standalone system. You just put in electrical power, you put in, of course, the input water, and you get out the ultra-pure water. There's no bidirectional coupling required with the electrolyzer. Secondly, we make sure it's really, really robust. That's why we chose the distillation technology rather than membrane-based technologies, because there we do not expect any downtime of the whole system due to water purification. So this way, it's also possible to really improve the levelized cost of hydrogen. Now, of course, you will have some investment into the system of water purification, and you do have some operating costs, but both these are at the order of a few % of the entire system. So it's small, but indispensable.
What's your personal prediction for the year 2050? Do you think something like this, or water treatment in general, will be a standardized off-the-shelf component? Or do you think we'll still be on this quest, this endless search for clean water?
Especially when I think of these innovative projects where we go in remote locations, those are challenges for water purification. So there's a lot to learn, but we will get there. We will get to standardization. We just need to trigger innovation now to come up with system designs that really enable sustainable water management altogether. My vision is that towards 2050, water scarcity and quality will really become an increasing problem that we have on this planet. And while ramping up the green hydrogen production, we need to make sure that besides reducing the CO2 emissions, we do not cause any other environmental issues, such as by adding chemicals into the surrounding water bodies. Green hydrogen is only sustainable if we avoid adding chemicals into the production process. We can tackle this challenge. And in my vision for 2050, we will have leveraged our innovative power and realized sustainable green hydrogen production. Where there is a water scarcity issue, we will use saline water sources, turning it into ultra-pure water for hydrogen on the one hand, and on the other hand, into drinking water after remineralization for people or for other use cases. So if we do it right, hydrogen projects will not run us into conflicts, but instead they will offer a dual use case for water.
Wolfgang, thank you very much for this very clear, optimistic and confident vision. And thanks for also making it so clear that this whole journey to the green hydrogen economy starts with this single drop of ultra-pure water. And I think you've definitely topped up my tank of optimism and enthusiasm for this whole topic. Thanks once again, Wolfgang.
Thank you, Keith. Thanks for having me.
Thanks to everyone for joining us for this latest episode at minus 253 degrees Celsius. It's the monthly expert talk that gets to the point, to the boiling point of hydrogen. And I hope to see you next time.